Hello everyone, me again. As I promised, today we're gonna talk about something about matrices and what matrices can do for us. In this example, there is no simulation involved, just some point deformation by using matrix. So let's dive right in. Okay, first we're gonna do some preparation. And let's name this one. I already made a example, so I call this one my wave touch or share, doesn't matter. So we're gonna put a grid, and this is our ocean surface, and I believe we need more resolution. And then we're gonna put a sphere here and do attribute transfer. We're gonna transfer what? We're gonna transfer color, and gonna set the grid to be black and the sphere to be red. And this is too much, I guess. So put this one back to 0, and then yeah, this is This is the readout. And remember, this one is very important. And set it to black and set this one to red so I can remember. If you don't do this, the result won't be good because the edges of the attribute transfer will be very harsh, right? So you got put it back. Put the CD. The number of the CD attribute back to 0, 0, 0. But if you don't do this, this will be 1, 1, 1. So the result won't be good enough, right? And why do I do this? Because I want to use the right information as a threshold. And so I put an all here to remember myself. And I'm gonna code this one thread. Okay. Yeah. Threshold. Yeah. Sorry if I can spell that. Okay. So here comes the today's topic, and we need an attribute angle, and we're gonna talk about the matrices. There are several kinds of matrices. And I'll show you what it looks like. So there are two kinds of matrices we often use, and the first one is called a transformation matrix. The transformation matrix has to be 4x4 matrix, as you can see, for rows and for columns, and there is a diagonal line, which is this line has to be 1, 1, 1, 1. This is very, very important. 1, 1, 1, 1. And this matrix is responsible for transformation and rotation and scale. All kinds of manipulation. And the second one is called the rotation matrix. And the formation is as this one is 3x3 matrix. And also, the diagonal line has to be 1, 1, 1, 1, 2. This one is responsible for rotation. And to our demonstration, we're gonna use a 3x3 matrix, also called Orient Matrix, to rotate the points at the center of the threshold. And if the sphere is moving, I'm gonna put a transform here, and if this thing is moving, we're gonna need a 4x4 matrix to put the vortex always at the right place. Let's set this one to red. That's my habit. So this node is very important to me, and in order to use a 3x3 matrix, we have to define the matrix. Say matrix 3. Matrix 3 means 3x3 matrix. And we're gonna call this one mat rot. So this is the rotation matrix. We're gonna use a ident, which means we're gonna define the identity of a empty rotation matrix. And then we're gonna use a function called rotate. And this function needs the mat rot matrix 3 and the angle and the axis. And then we're gonna define a float variable and called angle, and set this one to radians. I want to use, because I like to use degrees, 0 to 360 degrees maybe, and which we're gonna put in ourselves and call this one angle. It's the float, and we need a vector to define the rotation axis equals CHV. We're gonna put in ourselves, and we're gonna call this one axis. This is what we're gonna need. And now this is the default is between 0 to 1. We're gonna change that. I like to change this one to 0, from 0 to 360. And I want the rotation axis will be 0, 1, 0, aka y pluses. And then we're gonna do p multiply equal mat rot. And is anything changing? Oh, sorry, the wrong node. The whole grid rotates. That's not what we want. And that's why we need a threshold. We can use the threshold to control the angle. So the angle multiply equal at CD dot x. And that way, only the center part rotates. Yeah. That's what this one's for. Then we can control the depth of the vortex. Say p dot y minus equal the cd dot x attribute. And yeah, this is the readout. If I change this one back to white, maybe this more clearly. And we can control this cd dot x furthermore by multiplying ch depth. So this is multiply 1, and then we can multiply more than that, so we can control the depth of it. Okay. And I think we can furthermore manipulate this guy by using a power of a I'm gonna put it here. We're gonna say tell this one gamma and control the transition. The red transition, actually. If you ever wonder what's gamma, let me show you this way. I'm gonna put point up, connect the CD to the CD, and we're gonna make a color correction. And this is the gamma. Maybe I can show you at a E. So let's make a curve and put it here. So the curve is gamma. what gamma is. A gamma describes the relationship between x and y, and the highest point and the lowest point, they are fixed. Before, when the x is at 0.5, the y is at 0.52, right? And then we change the curve. So this time the x is still at 0.5, but the y changes, not 0.5 anymore. And this relationship is called gamma. Okay, back to where we were. And to now we are using a grid. And what about we use a ocean evaluate and connect it here, make an ocean spectrum. And well, I guess maybe this one's too low. Yeah, this is what we get. The ocean surface. And put it here. Still, we are transferring the CD attribute, and this is the readout. This readout is, yeah, it is ugly now. So maybe we're gonna need more resolution. With more resolution, this one is smoother. Let me see the readout. This is the readout. Maybe it's rotating the wrong direction, maybe? I never noticed that before. Just ignore that. And for now, the next problem is, what if this sphere thing moving? And can we do that? Maybe I put sine, dollar sign t, and multiply 100. Let me see what I got. And then maybe we're gonna put cosine this time. And the result should be, yeah, is rotating at a circle. And what do we get now? The result is pretty weird, right? That's because the matrix we just made, the 3x3 matrix, right? This guy just at the center. So whenever this one is not, the sphere is not at the center, there will be a problem. And how to fix that? In order to fix this problem, we're gonna need the 4x4 matrix, also called transformation matrix, and just connect it from here, and the transform sub can easily output in X form. And if you ever wonder, put it on the detail. You can see there are some numbers changing. This is 0 to 15, which is a 4x4 matrix. And we can fetch that. Also, we can define a matrix, and we're gonna call that matrix equals ident. Every time you make a matrix, you have to use the ident function to define a new one. And we can use a point function. Sorry, I remember that was on detail, so we're gonna use a detail function to fetch from the second connection, which is 1, and that one's called X form, because there is only one point. This is just 1 point. We can always use 0.0 to fetch that out, and then put that matrix in our matrix. Okay, so the matrix, we can see that. If we really want to see that, we can for it, and we can say for it Yeah, these column and this column, it should be, see, the 0.77, and this one be 0.77. We successfully copied it from the transform stop. And what we're gonna do next is to, let's put it back, because this is redundant if I define these as a attribute. This is variable. This is there's no nobody needs to see these numbers. Just use it here, and then we don't care about this one anymore. And then we're gonna say p equal multiply equal the matrix, and this one is still weird, right? That's because this one, if I just do this, this is the result. They are moving, but that's not what we want. What we want is to put wherever the center of the sphere is, just put it back at the center of the origin. We just need to multiply the invert of the matrix. This rotating part always at the center. And if I delete this, see, this time the result is more or less right. The vortex is always at the center, but the outer part isn't. The outer part is moving, which is not what we want. And you can see the grid is moving, and that's why at the end we gonna multiply that thing back. So this time the vortex moves again, but not the grid. I lowered the angle. Before it was about 600, and I lowered the angle, and the result should be okay. This one is still not that good, I believe, but I think we can still do some changes to make this one great. So yeah, like what I did, put it here, lower that, lower the saturation. Don't want to see this. That's how I did it, and that's how the matrix can do for us. Just remember two kinds of matrices, 3x3 and 4x4. One for rotation, one for all kinds of manipulation. So that's for today. Hope you found this video useful, and see you next time.